Hi everyone. Last video we were discussing on the introductory part of syntax directed definition. We also saw how adding semantic rules onto this context-free grammar converts an context-free grammar into a syntax directed definition. The second thing what we were discussing was how this syntax directed definition helps us in evaluating the type expressions and then evaluating certain values, so on and so forth, creating intermediate code generation and so on. And the third point which we discussed in the last video were the type of attributes. Now, what are the type of attributes? The attributes which are associated with any grammar symbol can be classified into mainly two type of attributes. The first one is synthesized attribute and the second one is inherited attribute. What is synthesized attribute? For an attribute which is associated with any the grammar symbol on the left hand side, we should know all the attributes of the grammar symbols onto the right hand side of the production so as to evaluate the attribute on the left hand side of the production. But what about inherited attribute? In inherited attribute, it's not so. I can take the attribute value of the left hand side grammar symbol and also all the grammar symbols to the left of it, which means if I have to evaluate a value of t, I should know the value of its parent e and the left hand side grammar symbol e1. Then it is an inherited attribute. But here we are calculating the value of e based on its child nodes. We should know e1's value and t's value, and therefore it is a synthesized attribute. So these were the points we discussed in the previous video. Now, to define something called as S-attributed definition. Now, first we'll think what is an attributed definition. We'll give some more insight onto what an attributed definition is. In a syntax directed definition, if we are giving importance to evaluation of attributes, here the attribute is val and lexval. If we are giving importance to the evaluation of attributes which are associated with any grammar symbol, we call it as an attributed definition. Now this attributed definition can be of two types. One is S-attributed definition and the other one is L-attributed definition. Now we'll see what an S-attributed definition is. If we are evaluating the grammar symbols and all the attributes are synthesized attributes, then the attributed definition becomes an S-attributed definition. So we'll start from the syntax directed definition. The next step is, if we are evaluating only the attributes, we call the syntax directed definition as S-attributed definition. And based on the type of attributes we evaluate, we call it as an S-attributed definition. So if a production has a set of semantic rules and all the semantic rules consist of only synthesized attributes, then we call it as an S-attributed definition. And therefore, the example what we saw for synthesized attributes holds good for S-attributed definition, because here I should know the value of E, here I should know the value of E1 and T here. Only if I know the value of the child, then I will be able to calculate the value of the parent node, or in other terms, only if I know the value of the grammar symbols on the right hand side of the production, I will be able to calculate the value of the grammar symbols on the left hand side of the production. So that is what we call it as an S-attributed definition. Moving on, you have one more type called as L-attributed definition. Now what is L-attributed definition? Even if one of the attribute is an inherited attribute, all others can be synthesized. One attribute, if it is an inherited attribute, we call it as an L-attributed definition. Now there is a difference between how we define S-attributed definition and L-attributed definition. Suppose you have 5 attributes to be evaluated in a given attributed definition, which means a syntax directed definition. And all the 5 are synthesized attribute we call it as an S-attributed definition. All 5 attributes which has to be evaluated should be synthesized attributes. But for L-attributed definition, you have 2 cases. One is all synthesized attributes can also occur. So an S-attributed definition can be an L-attributed definition. But then if one attribute is an inherited attribute, then you call it as an L-attributed definition. So now what happens here, we'll go on with the example first. Now here, if I have to know the value of L, here what are we doing is, in a nutshell, we are talking about the declarative statements. The declarative statement produces type, space, the literal. It's similar to int a, comma b, and so on and so forth. That is what they are given here. In this grammar, they have only concentrated on int and real type. So now, if I have, for example, I have int a. If I have to associate the data type integer to a, I should know what is behind it. So I should take the value of types attribute and assign it to the L attribute, and therefore this becomes an inherited attribute. Now we take the next one. I should know int as such to assign it to t dot type. Similarly, I should know real. I can assign here. So now you have a mixture of synthesized and inherited attributes. Therefore, we call it as an L attributed definition. Moving on to the definition, a syntax directed definition is L attributed if each inherited attribute xj. Now what is xj? They are generalizing the production, saying left hand side you have the non-terminal a, right hand side I can have any number of grammar symbols. So every grammar symbol we are generalizing. I can have n grammar symbols, so we'll take it as x1, x2, xn. Now if I have to evaluate the value of xn, I can take the attribute values from a to xn minus 1. But if I have to evaluate the value of x2, I should take the attribute values of only a and x1. I cannot take the attribute value of x3, which means I cannot take the attribute value of the grammar symbol which lies to the right of the given grammar symbol. So that is what they mean here. So if I have to evaluate the value of xj, I can take the value of x1 to xj minus 1, and therefore I call it as an inherited attribute. Now the last is what we said earlier. Every S attributed definition is an L attributed definition, but the restrictions is only on the inherited attributes. If I have one inherited attributes, it has to be L attributed, not S attributed. But for S attributed, all the attributes has to be synthesized attributes. Now there is another case. Now we'll take another example saying A produces QR and A produces LM. If you take L, to evaluate the value of L, I should know the value of A. So this becomes an inherited attribute. If I have to evaluate the value of M, I can take the value of L and A. So this is also an inherited attribute because it takes the value of L here. But look at here, you have A dot S. So A's value is evaluated by some function. At this I, M and F for certain functions they are given. So some function and the attribute of M is used. So I am using the attribute of child node. So L is an inherited attribute. This M's attribute will be inherited, whereas A's attribute is synthesized. What about R? R, we are trying to evaluate it from A's value. Therefore, R is inherited. Q's attribute, Q is using something on the right to it. What can inherited accommodate? Inherited can accommodate only the attributes of the grammar symbols to the left of it. So now Q is using some attribute value to the right of it, which is not an inherited attribute. So if your attribute doesn't fall into synthesized and it doesn't also fall into inherited, then you call it as an non-inherited attribute. If such kind of attributes are there in our definition, then we call it as a not L attributed definition. So we have now three main classifications are S attributed and L attributed, whereas the third one is not L attributed definition. So these are the three types of attributed definitions we have. And next slide we'll talk about how you evaluate an S attributed definition. Usually S attributed definition we evaluate it based on the bottom up evaluation model. So now what they have given, as we read X, Y and Z, the values of attribute values of X, Y and Z are popped inside. So this is the value top. So you have top -1, top -2. You take everything and then you evaluate it and put the value as A here. So what it's similar to the LR parsing what we do. We pop out till what you have on the right hand side, evaluate it and push it as an attribute to the left hand side. That is what we are doing it here. So now what happens, it is bottom up evaluation of S attributed definition. What do we do here? When I have a digit, we normally push it onto the top. So now what if I take this part alone, this is top -2. The value of E will be placed in top -1. Just forget of all the grammar symbols. Sorry, state symbols. We'll just take the grammar symbols alone. So if I take a stack, we'll assume that the stack comes only for the right hand side. So now this is top -2, this is top -1 and this is top. So now what value should I take? I should take the value of E. So now that is there in top -1. And once we push off till opening parenthesis, we create a new top. And new top is explained here as the n top. So value of n top. What is value of n top? F's value will be equal to value of top -1 because E is here in middle. Now here we are not going to change anything. It's just assigning. So there's no change in the top value. We are just retaining as such. Here it is value of top -2, top -1 and top. So you take the value of top -2, multiply it with value of top and find a new top and assign it there. So till then you pop it out. Here is just the copying again. Here it is top -2, top -1 and top. So we are taking value of top -2 and value of top, adding it and assigning it to the new top. That is what for given for the left hand side variable. Now this is top -1, this is top. So you take value of top -1 and print it. This is how we evaluate using bottom up parsing technique. So far we have seen what is an S attributed definition, L attributed definition, not L attributed definition, and also bottom up evaluation of S attributed definitions. Thank you.